I'm Tunjian, so currently a vLLM maintainer. And yeah, I'm honored to be here for the first vLLM meetup at Bangkok in Thailand. So let's get started. Yeah, Usman already introduced, but I'll go ahead like basically what embedded LLM is working on. So we are trying to, our vision is to make like vLLM everywhere so that you can just host any models that you want on any hardware that you can get based on where your budget, etc. Then and also our company has other products that we have this mission where we want to build a like sort of like federated AI utilities that fully powered by vLLM, so that you can run your model as fast as possible on any hardware that you can get. Yeah. So and this is the vLLM's goal. So we are trying to build the fastest and easiest to use open source like LLM inference and serving engine. Well, yeah, Usman also introduced, but I'll go in my version. So what is vLLM? So first of all, we know about ChatGPT, okay? And ChatGPT actually is just like a model. Models usually comprises of the weights. And usually what we are more accustomed to when we talk about ChatGPT is like you have an interface where you would chat with it, chat with GPT. So, and what's in between is actually vLLM. vLLM is the OS for LLM models. It runs all those weight, and then so basically when you have the application, you send your request to this OS, like our own computer, it will process it and then it will generate output to you. Yeah. And this OS has been greatly adopted by the sort of like everyone else. Like even the large enterprises, they are also using that. It's currently it's so popular that we already have like 63.6K GitHub stars already. And we have been deploying like GPUs, like 500K GPUs, 24/7s in order to sort of like run, make sure that all the codes are running well through the CIs, and also we are running some benchmarks. So later on you will see like there's dashboards that are out there that you can take a look at the performance on like different hardwares. Yeah. And yeah, feel free to join us on Slack. Right now we have like 9K members already. And it is one of the largest scale collaborative projects. Yeah, we have a few hundred PRs per month, and now we have like 1,700 plus contributors. And majority of contributors are from like Red Hat, Meta, and Skill, and yeah, embedded LLM. So just recently, basically we have been awarded as one of the top open source projects on GitHub. So vLLM has grown into an ecosystem of models and accelerators and also frameworks. So all these models that you have been heard in the news, Kimi K2, Llama, GPT-OSS, DeepSeek, so they runs on vLLM. And for any hardware that you could imagine, like Intel, AMD GPU, NVIDIA GPU, Google TPU, and even the rest like Gaudi, IBM Sparrow, MetaX, all those runs on vLLM as well. And for those like models trainers, I know there are some models trainers over here. So it has been deeply integrated into many of the RL training frameworks. So Unsolved, all those like you heard them quite often. And also we have a very broad sort of like embedded into the broad Kubernetes orchestration systems. So they are like vLLM production stack, LMD, which is product of Red Hat, and there's Array, SkyPilot, etc. And there are also other sort of like inference research works that builds on top of vLLM to further accelerate them. So they are like X-infer, Arctic inference, and also LMCache. And this year, basically, vLLM, we know that it heavily utilizes all the optimizations features from PyTorch. Like, for example, torch compile, flex attention, all this. So we are happy to be able to join the PyTorch Foundations, where in these PyTorch Foundations, we get all these sort of like benefits so that we can ensure that VM CIs are running, we have enough compute, so that we can make sure that we deliver the best software out there so that you can run your LLM models. Yep. And yeah, basically these are all the new PRs of the new features that are basically showing that it has been integrated at the sort of like day zero into a vLLM from PyTorch. So let's get us with like vLLM. How do you use it? So there are various sort of ways you can use vLLM. The easiest one would be just like this. Basically, it's like a OpenAI. It's like the Transformers libraries interface. You create a model using LM object, and then you just LM.generate, and that's your prompt. Another way would be hosting your models through a OpenAI compatible server, which is what you guys are more familiar with, most of you. Yeah, so you just vLLM serve, and then you send basically your code request that follows the OpenAI format. Well, and recently we have added a few more ways to interact with vLLM. One of it is this agentic API, which is called the Response API, proposed by OpenAI. We also support the Cloud Code compatible API as well. Yeah, so feel free to explore, and if there's, because this API is relatively new, so feel free to contribute if there's some missing features in there. Yeah. Well, now we know like what features vLLM have. So, but what's the experience with if you started using vLLM? So we have been delivering like the state-of-the-art multimodality performance over here, and also there might be new models that architectures that you have you created, and then you haven't implemented your model definition file in vLLM. Fret not. Basically, we have the Hugging Face has implemented this transformers backend. Basically, you can automatically swap out the modules in your transformers libraries model definition file with the modules that you get from vLLM, so that you can capitalize the optimization that you get from vLLM directly without needing to like write your model definition file in the vLLM. Yeah. Text model is broadly supported, and some of the visual language models are like supported, but it's, audio models are not supported yet. Yeah, at this moment. Yeah, and vLLM offers various like parallelism. As I guess you guys have heard about like DeepSeek. They have been deploying on like hundreds of GPUs doing like expert parallelisms, pipeline parallelisms, PD disaggregate, inferencing. So all these features, they are already there and stable in vLLM. And yeah, I mentioned before, so we have a sort of like native support for all this reinforcement learning framework. And yeah, in vLLM, we strive to ensure that the accuracy is there. So whatever the model vendors promise in their sort of like research paper. So basically, we like, for example, in GPT OSS, we have been receiving it like within for like 1 week. So they have been cramping their time in order to make sure that the GPU OSS deliver the same performance as the one that OpenAI has promoted. And another thing for those who are training models, so currently we have this batch invariance kernels in there in VM already, so that it ensures that the logics that you get for your RL training is stable and is reproducible. Yeah. So yeah, we prioritize performance. So how, like when we say we prioritize performance, we need to be able to measure it. So yeah, just now we have been honored to be joining a PyTorch Foundation. So they have been providing all those like computes, like AMD GPUs, NVIDIA GPUs, and recently like Intel Gaudi has added to their benchmarking site. So this is a link, you can check it out to see like performance of some of the models that they have been tracking. And yeah, CI is not cheap. So that's why we require a large sort of like foundation and fundings to make sure that the CI runs 24 hours so that all PRs are validated so that we deliver quality softwares. This is a very quick summary of what like V1's performance feature that has been landed this year, like the highlights. Main thing is like torch compile. Basically, automatically compiles a very efficient code from your PyTorch native's implementation. And another thing is like flexible CUDA graph. So basically, because there are some components that are not compatible with CUDA graph, like linear attention, etc. So vLLM provided that interface that you can exclude that attention and then make sure that all other gems, quantization ops, etc., they are still in the CUDA graph so they can benefit from it. And yeah, now it is a new era where it has been like sort of like pioneered by authors like Mamba, etc. And then the most recent like noticeable notable model is like Quern 3 Next. So they are using hybrid kind of KV cache, interleaving like sliding windows and also dense attention. So basically, vLLM has been able to support that natively so that it saves up memory. Yeah, you can basically use it to inference like processing a very long prompts with very limited VRAMs. And yeah, the KV connectors. Basically, that's in PD inferencing, that's very important. You need, like, for example, on NVIDIA side, you have Nixel for transferring like KV caches between your P instance and the D instance. So we have these connectors abstraction in there. Yeah, let's recap. So VRMs, we deliver timely, accurate, and also optimized model support and a wide range of hardware coverage that you guys have seen already. And yeah, we have a flexible API with variety of integrations such as RL framework. And yes. And the frontier innovations that has been landed are like FuseMOE modular kernels. So this allow us to cleanly interface with, like, for example, DeepSeek, Perplexity kernel, and on AMD side recently we have the Mori auto backend, etc. And yeah, we have the torch compile, hybrid memory management, KV connectors, and the fine-grained CUDA graph. Yeah, so yes, this is our goal. So we welcome everyone to be a part of this community, contribute to it, and then you can join basically the Slacks, our X, and link in to get latest updates like what's going on in VLM. Yeah. So and also thanks to all the contributors that are maybe could be here. So thank you for contributing to these projects. Yeah. But yeah, how do we go further with VLM? Yeah, so LMCache. Just now you have seen this symbol, I would say. So basically, they are our partners and also the sponsors of one of the sponsors for today's event. Unfortunately, they cannot be here. But why they are so important? Like they are one of the sisters projects for VLM. So how do they accelerate like VLM further? Is they are trying to build a faster sort of like solution that can transfer KV caches between inference engine and also like storage hardware. Yeah. On VLM, basically just now I mentioned about the KV connectors API. So LMCache uses that KV cache connector so that it could store the KV caches on various storage. It could be on your disk, could be on your CPU RAM, And also it could be the others like remote storage, like Redis, Weka storage, Infinity Store, all those. So basically why this is important is that, for example, like you are serving like 1 million users, and then you have a few hundreds of servers, and there are common questions like between users, and sort of like allow you to not to recompute the same prompt, the KV cache of the same prompt, you can store it at a storage that basically is a share pool storage that stores all the KV cache, and then when there's a cache hit, then you can directly just retrieve that KV cache to your LM engine, which is with the vLLM. So that greatly improves sort of like your time to first token experience. Yeah. Here currently, it has been the de facto standard for like KV caching in open source. So it has been integrated in various platforms as well, like vLLM production stack, NVIDIA's Dynamo, LMD, or Kserve, and SGLang also supports that. Yeah. So currently, they have been used for a very long time. So they accumulated like sort of like 300 TB of KV cache data, and 1.28 billion like hit tokens like weekly. Yeah. So they have been deploying like on an enterprise setting as well. Yeah. And currently, yeah, it's same as vLLM. So it's an open source project. So they have garnered like 100 plus contributors from global AI community already. And it's also one of the PyTorch ecosystem projects this year. Yeah. And it has been sort of like one of the fastest growing like KV cache related optimization open source projects. Yeah, so it has been widely adopted amongst like different partners and also some of the early adopters, including like Bloomberg, Tencent, all those companies that you guys are also familiar with. So yeah, let's take a concrete figure like what's the performance that you, like the performance that you can get from using LMCache. So this is one of the use cases that they have been studying. So it's a Llama 3.1B on a 1H100, and the input is like 20K tokens. It's extremely long input. Yeah, and it will plus 10 like tokens query. And then they're like simulating like 40 users, 20 rounds per users. So overall, they have seen like they are like 5 to 10 times faster in terms of like TTFT, and 2 times faster in ITL, inter-token latency, under high request rate. So it's a very marvelous work. So after you use LM and then you want to go further, you can try out LMCache. And currently, actually, they have been deploying like some demos on a web page at here. You can go to app.tensormesh.ai. So they have this interface that you can sort of like quickly deploy the vLLM with LMCache enabled. Yeah. Click and then just fill out some of the fields. I know it's a bit blurry over here. Yeah. But it's relatively simple. Just fill out like what's the hardware spec that you need, and you click deployment, and then just let it run. And yeah, basically you can ready to start to serve and chat just like a regular like vLLM serve. Yeah. So yeah, they are hiring. Okay. Right. Thank you so much. Hope you guys learned something, and I hope I didn't bore you. Okay. I'll pass the stage back to Usman.